In this video, we will make explicit something we were doing in calculations in the previous video. We're going to make it explicit and expand the idea a little bit. When a method of counting yields repetitions, that is, the same thing is counted more than once, we have to divide by the total number of possibilities by the time each item was counted. So that's what we're doing in the previous video. How would the same thing get counted more than once? Well, one way, of course, is if we have identical items. And so when we put those identical items in different orders, you can't tell. But another way has to do with orders, whether we care about order or not. Remember that our fundamental approach so far has employed the fundamental counting principle, which analyzes outcomes one choice at a time so that order matters. Order automatically matters when we're using the fundamental counting principle. If we're only concerned about the final element selected and the order doesn't matter, then different orders of the same item constitute repetitions of the same thing. And so this is where we can start the conversation about order. And in a counting problem, it's always important to be aware, are we concerned about order or not? And if we're using the fundamental counting principle, we're automatically going to do the calculation that corresponds to caring about order. In this video, we're going to analyze some of these situations from the perspective of the fundamental counting video. In upcoming lessons, we will talk explicitly about combinations and ways to compute them. So a combination is what we're counting when we don't care about order. And so we'll talk more about that in upcoming videos. But right now, it's very important to understand that everything in counting, including permutations and combinations, fundamentally comes from the fundamental counting principle. The fundamental counting principle is the big idea, and everything else in counting is dependent on that idea. So here we're going to jump in with a fundamental counting principle approach. Suppose there is a room of 20 people, and each one will shake hands with the other person. How many handshakes occur? One way to approach this is to realize that each one of the 20 people shakes hands with 19 other people. One might think the number would be 20 times 19, but that would be too big. It would count every handshake twice. In other words, that would count me shaking hands with Elliot, and it would also count Elliot shaking hands with me, but that's only one handshake. Elliot and I shake hands, and it doesn't matter which person there's not like one person as the starting point in a handshake. Just two people are shaking hands. And so 20 times 19 would count everything twice. It would count it once as one of my handshakes and once as one of Elliot's handshakes, and so that would overcount. And so we actually have to divide by 2 to get the correct answer. 20 times 19 divided by 2, and of course that's 10 times 19, which is 190. Here's a practice problem. Pause the video and then we'll talk about this. Okay. In geometry, diagonal of a polygon is a segment from any vertex to any non-adjacent vertex. For example, a diagonal from K could go to any vertex from A to I, but it could not go from J to L, because obviously there's a side going from K to L and K to J. How many diagonals does a regular 12-sided figure have, a regular dodecagon? So choose any starting vertex. For that, we have 12 choices. Step 1. Then, how many non-adjacent different vertices does it have? So if we start at A, well, for the second vertex, we can't pick A again. We can't pick B or L, which is right next to A. So there's 3 that we can't pick, so there's 9 that we can. And so that's 9 times 12, but just like the handshakes, everything's getting counted twice. Because if we say this diagonal right here from A to E, that's getting counted once as one of A's diagonals, but it's also getting counted once as one of E's diagonals. But of course, there's only one diagonal here. We don't need to count it twice. So we have to divide by 2, and so that's 6 times 9, or 54. And so there are 54 diagonals in a regular 12-sided dodecagon. This is precisely what we're doing in the previous video on repeated elements. For example, we learned in that video if 3 elements are identical, then we divide by 3 factorial, or 6, in order to eliminate repetitions. So here's a practice problem. And again, this is a practice problem you can do from the fundamental counting principle perspective. Pause the video and then we'll talk about this. Okay. From a set of 10 different identical items, Lisa is going to select 3 as a gift for someone. How many different sets can she pick? And so this is an example where order does not matter. It's just going to be a set of 3 gifts. It doesn't matter what order she picks them. So using what we've learned so far, fundamental counting principle, there are 10 choices for the first gift, 9 choices for the second gift, 8 choices for the third gift, but that doesn't take into account, that would count all the possible orders, and we don't care about orders. Because we don't care about orders, and we would have overcounted by 3 factorial, or 6, so we have to divide by that. So this is an example of the 6 different arrangements of the same 3 gifts. So all 6 of those just count as one set of gift. We don't need to count it 6 times. So the 10 times 9 times 8 is 6 times too big. So we're going to divide 10 times 9 times 8 times 3 factorial. 3 times 2, we're 6. Then we can divide out the 3, cancel the 3 with the 9, cancel the 2 with the 8 to get 4, and then go 3 times 4, which is 12, times 10 is 120. And that's the number of different sets that she could pick. In that problem, we wanted a collection of 3 items, and we didn't care about the order of items. In this video, we saw that we could calculate the right answer using the fundamental counting principle and then eliminating repetitions. In coming videos, we will learn another approach. We'll learn that this collection is called a combination, and we have other ways to calculate a combination. And I'll point out that you really understand a math problem if you know multiple ways to calculate it. In summary, when we count, we must eliminate repetitions. We do this by dividing by the total number of times each arrangement is repeated.